When installing a direct buried 200 peg copper phone line between two buildings in proximity to the main power service, it is critical to adhere to the National Electrical Code, specifically Section 800.56 of the 2020 edition, which addresses the separation requirements between telecommunications cables and power conductors. The key consideration here is the potential for interference and safety hazards arising from the close proximity of these systems. Section 800 addresses communications circuits, and Part 56 specifically addresses the installation of these conductors with power conductors. Section 800.56 provides guidelines for direct buried cables. According to the NEC 2020, Section 800.56a, the minimum required separation distance between a direct buried telecommunications cable such as your 200 peg copper phone line and a power line conduit is 12 inches or 305 millimeters. This 12-inch separation is essential to mitigate the risk of electrical interference, accidental contact, and potential damage to the telecommunications cable. This requirement applies specifically when the power feed is encased in a conduit. Conduit provides a degree of physical protection for the power conductors, but the NEC still mandates the 12-inch separation to ensure an adequate safety margin. However, an exception exists if the telecommunications cable itself is installed within a raceway. A raceway is defined as an enclosed channel designed expressly for holding wires, cables, or busbars, with additional functions as permitted in the NEC. Raceways can be made of metal or insulating material. Examples include conduits, electrical metallic tubing, or even rigid polyvinyl chloride. If the 200 peg copper phone line is placed inside a raceway, the minimum separation distance from the power line conduit can be reduced to 6 inches or 152 millimeters. This reduction is permitted because the raceway provides an additional layer of physical protection and electrical isolation for the telecommunications cable. It's crucial to understand that these separation distances are minimum requirements, and in certain situations, exceeding these distances might be advisable. For instance, if the voltage of the power conductors is high, increasing the separation distance beyond 12 inches could further reduce the risk of interference or accidental contact. When planning your installation, carefully consider the specific conditions of your site and consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. Factors to consider when determining the appropriate separation distance include soil conditions, the presence of other buried utilities, and the voltage of the power conductors. For example, if the soil is highly conductive, it may be necessary to increase the separation distance to minimize the risk of electrical interference. Similarly, if there are other buried utilities in the vicinity, such as gas lines or water pipes, it is important to maintain adequate clearance from these utilities as well. The NEC also addresses the burial depth of both telecommunications cables and power conductors. Generally, direct buried cables must be buried at a sufficient depth to protect them from physical damage. The specific burial depth requirements vary depending on the type of cable, the voltage of the power conductors, and the location of the installation. Consult the NEC for the applicable burial depth requirements in your specific situation. In addition to the separation and burial depth requirements, the NEC also addresses the grounding and bonding of telecommunications cables and power conductors. Proper grounding and bonding are essential to minimize the risk of electrical shock and to protect equipment from damage due to lightning strikes or other electrical surges. Ensure that your installation complies with all applicable grounding and bonding requirements. Furthermore, it's crucial to use appropriate materials and installation methods when working with both telecommunications cables and power conductors. Use only cables and conductors that are listed and labeled for the intended application and follow the manufacturer's instructions for installation. This will help to ensure the safety and reliability of your installation. Remember that the NEC is a comprehensive document, and it's essential to consult the latest edition for the most up-to-date requirements. Electrical codes can change, so staying current is vital for compliance and safety. In summary, when installing a direct buried 200 pair copper phone line in proximity to a power line conduit, adhere to the following guidelines. Firstly, maintain a minimum separation distance of 12 inches or 305 millimeters between the telecommunications cable and the power line conduit, as mandated by NEC 2020, section 800.56a. Secondly, if the telecommunications cable is installed within a raceway, the minimum separation distance can be reduced to 6 inches or 152 millimeters. Thirdly, consider increasing the separation distance beyond the minimum requirements if warranted by site conditions or the voltage of the power conductors. Fourthly, ensure that both the telecommunications cable and the power conductors are buried at the proper depth, as specified in the NEC. Fifthly, follow all applicable grounding and bonding requirements. Sixthly, use appropriate materials and installation methods. Seventhly, consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. By following these guidelines, you can ensure a safe and reliable installation that complies with the NEC and minimizes the risk of electrical interference or accidental contact. It's also worth noting that local codes and regulations may impose additional requirements beyond those specified in the NEC. Be sure to check with your local authorities to determine if any additional requirements apply to your installation. Always prioritize safety when working with electricity. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to perform the work. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. When working with direct buried cables, it is also important to be aware of the potential for damage from digging or other excavation activities. Before digging, always call your local one-call center to locate any buried utilities in the area. This will help you avoid damaging underground cables or pipes. Damaging underground utilities can be dangerous and can also disrupt service to homes and businesses. By taking the time to locate buried utilities before digging, you can help prevent accidents and ensure the safety of yourself and others. Remember, the NEC is not a substitute for good engineering judgment. It is important to carefully consider all aspects of your installation and to make informed decisions based on your specific site conditions and the requirements of the NEC. If you have any questions or concerns, consult with a qualified electrical inspector or engineer. Staying informed about electrical codes and best practices is crucial for anyone working with electrical systems. By taking the time to educate yourself, you can help ensure the safety and reliability of your installations. Also, consider the practical implications of the NEC requirements. While the code provides a framework for safe electrical installations, the actual implementation requires careful planning and execution. This includes selecting the right type of cable for the application, ensuring proper support and protection for the cable, and using appropriate connectors and terminations. The NEC requirements for separation distances are not arbitrary. They are based on years of experience and research, and they are designed to protect people and property from the hazards of electricity. Ignoring these requirements can have serious consequences, including electrical shock, fire, and equipment damage. The NEC is a living document, and it is constantly being updated to reflect changes in technology and best practices. It is important to stay current with the latest edition of the NEC and to understand the rationale behind the code requirements. Many resources are available to help you learn more about the NEC, including books, online courses, and seminars. Consider investing in these resources to enhance your knowledge and skills. When working with electrical systems, always prioritize safety. Wear appropriate personal protective equipment, such as safety glasses and gloves, and follow all safety procedures. If you are not comfortable performing a particular task, do not hesitate to ask for help. It is better to be safe than sorry. The NEC is a complex and comprehensive document, but it is essential for anyone working with electrical systems. By understanding the NEC requirements and following best practices, you can help ensure the safety and reliability of your installations. The 12-inch separation distance is not just a number, it represents a critical safety buffer. It minimizes the risk of inductive coupling, where electromagnetic fields from the power conductors can induce unwanted voltages in the telecommunications cable, potentially disrupting communication signals or even damaging equipment. The 6-inch allowance for raceways acknowledges the added protection they offer. A grounded metal raceway, for example, can act as a shield, intercepting electromagnetic interference and diverting it safely to ground. However, the raceway must be properly installed and grounded to provide the shielding effect. It is not enough to simply enclose the cable in a pipe. The entire system must be designed and installed according to the NEC requirements. Furthermore, the type of soil in which the cables are buried can affect the required separation distance. Soil with high moisture content or high mineral content can be more conductive, increasing the risk of electrical interference. In such cases, it may be necessary to increase the separation distance or to use other mitigation techniques, such as grounding the telecommunications cable at multiple points. The NEC also addresses the issue of stray currents. Stray currents are unwanted electrical currents that flow through the earth or other conductive paths. These currents can cause corrosion of underground cables and pipes, and they can also interfere with telecommunications signals. The NEC provides requirements for minimizing stray currents and for protecting underground cables from corrosion. When installing direct buried cables, it is important to consider the potential for future excavation activities. Mark the location of the cables clearly so that they can be avoided during future digging. Also, consider using a detectable warning tape above the cables to alert excavators to their presence. The NEC is not just a set of rules. It is a reflection of our collective knowledge and experience in the field of electrical safety. By following the NEC requirements, we can help protect ourselves and others from the hazards of electricity. The purpose of the NEC is the practical safeguarding of persons and property from hazards arising from the use of electricity. It's reissued every 3 years and is developed through a consensus standards development process. Various stakeholders are part of the process, including manufacturers, insurance companies, inspectors, fire marshals, and more. It is sponsored by the National Fire Protection Association. The NEC is adopted by state and local jurisdictions. These jurisdictions may amend the NEC. Therefore, it's important to check with the local jurisdiction about what is required in their region. There are many sections in the NEC. The NEC is organized by chapters. Chapter 1 covers general requirement. Chapter 2 covers wiring protection and methods. Chapters 3 and 4 cover equipment and devices. Chapters 5, 6, and 7 address special occupancies, special equipment, and special conditions respectively. And finally, Chapter 8 concerns communication systems.